I, Dr. Muhammad Akram, Department of Eastern Medicine, Government College, University, Faisalabad. I will discuss now about protein metabolism and especially urea cycle. Urea cycle is a synthetic process which converts ammonia into urea. Ammonia is toxic, water insoluble substance produced by amino acid catabolism. Urea is less toxic, water soluble, and a major disposal form of ammonia. Urea is readily excreted by the kidneys and it accounts for about 90% of nitrogen containing components of urine. Urea cycle occurs in liver. Enzyme for the first two reactions of urea cycle are found in mitochondria. Therefore, first two reactions occur in mitochondria and the enzyme for the remaining reactions are found in cytosol. Hence, the remaining reactions occur in the cytosol. Substrate for urea cycle. The first nitrogen of urea molecule is provided by free ammonia. The second nitrogen is provided by aspartate. Glutamate is the intermediate precursor of both ammonia through oxidative deamination by glutamate dehydrogenase and aspartate through transamination of oxaloacetate by aspartate transaminase. The carbon and oxygen of urea molecule is derived from carbon dioxide. The energy required to start the cycle is provided by two molecules of ATP. Steps of urea cycle. Carbamyl phosphate synthase is the rate limiting enzyme of urea cycle. Ornithine and citrulline are basic amino acids that participate in the urea cycle. Ornithine is regenerated with each turn of the urea cycle, much in the same way that oxaloacetate is regenerated by the citric acid cycle. Citrulline is transported to cytosol where it combines with aspartate to carry out the rest of the reactions. Arginine, semi-essential amino acid, produced in the cycle acts as an immediate precursor of urea. The enzyme arginase is found only in liver, therefore urea is formed only in liver, whereas other tissues can synthesize only arginine, not urea. Fumarate formed enters the tissue cycle. Fate of urea. Urea diffuses out from liver into blood and then transported to kidneys from where it is excreted out in urine. A portion of the urea diffuses out from the blood into the intestine and is cleaved to carbon dioxide and ammonia by bacterial urease. This ammonia is partly lost in pieces and partly reabsorbed back in the blood. Regulation of urea cycle. N-acetyl glutamate is an essential activator of carbonyl phosphate synthase, the rate limiting enzyme of urea cycle. The intrahepatic concentration of N-acetyl glutamate increases after the ingestion of a protein rich meal, leading to an increased rate of urea synthesis. Clinical importance of urea cycle. Urea is synthesized in liver and is excreted by kidneys. Normal blood urea level is 20 to 40 milligram percent. Urea level below 20 milligram percent points out defect in liver. Liver is unable to synthesize urea. Urea level above 40 milligram percent points out defects in kidneys. Kidneys are unable to excrete urea. In patients with renal failure, plasma urea level rises, hyperuremia, promoting a greater transfer of urea from blood into the gut. The intestinal action of urease on this urea becomes a clinically important source of ammonia, contributing to hyperammonemia, often seen in these patients Oral administration of neomycin reduces the number of intestinal bacteria responsible for this ammonia production. In patients with liver failure, ammonia will not be converted to urea, resulting in its high level in blood causing hyperammonemia. Ammonia can cross blood-brain barrier and can enter brain cells. Once ammonia accumulates in brain, encephalopathy ensures, which may result in hepatic coma and death. Nitrogen balance. Primary source of nitrogen for the body is dietary proteins. And as amino acids are oxidized, nitrogen is converted to urea and excreted out in urine. Other nitrogen containing compounds formed from amino acids are also excreted in urine, for example, uric acid, creatinine, and ammonium. Nitrogen balance, the normal state of nitrogen in adults occurs when the synthesis of body proteins equals degradation. Nitrogen balance equilibrium. To determine the nitrogen balance, the total amount of nitrogen ingested and eliminated from the body is measured over a certain period of time under condition of equilibrium as in normal adults. These values are equal. The amount of nitrogen ingested each day equals the amount of nitrogen excreted in urine each day. Positive nitrogen balance. It can be defined as nitrogen ingestion is more than elimination. For example, during growth, uh, wasting, illness, and during pregnancy. Negative nitrogen balance, it can be defined as nitrogen elimination is more than ingestion, for example, in starvations, wasting, diseases, fever, afterburns, surgical operations, and when food is deficient in proteins and essential amino acids. Ammonia metabolism. Ammonia is an extremely toxic waste product of amino acid catabolism. Even slightly elevated level can cause serious CNS damage. In human body, ammonia, water insoluble, is transported from peripheral tissues very efficiently to liver, where it is converted to urea, water soluble, and is then excreted in urine. Causes of low level of ammonia. Despite the fact that ammonia is constantly produced in the body in large amounts, it is present only in very low concentration in blood. The reasons are: liver rapidly removes ammonia from blood in the form of urea. Many tissues, particularly muscles, release amino acid nitrogen in the form of glutamines or alanine rather than a free ammonia. Sources of ammonia. In liver, ammonia is formed from the catabolism of amino acid by transaminase and glutamate dehydrogenase reactions. In intestine, ammonia is formed by the intestinal bacteria during hydrolysis of glutamines or by the degradation of urea. In kidneys, ammonia is formed by hydrolysis of glutamine by the action of glutaminase. Most of the ammonia is excreted by the kidney as ammonium, which is an important mechanism for maintenance of acid-base balance of the body. Amines from the diet and monoamines of hormones or neurotransmitters form ammonia by the action of amine oxidase. Metabolism of epinephrine, serotonin, and histamine. Amino acids are also released as ammonia from the metabolism of nitrogen bases, purine, and pyrimidine. Transport of ammonia in blood. Glutamines provides a non-toxic storage and transport form of ammonia. Formation of glutamine occurs in the liver and muscles and also in the CNS, where it helps in the disposal of ammonia from brain. And glutamine is formed in the plasma in high concentration than any other tissues. Circulating glutamine is removed by kidney through determination deamination by glutaminase. Thank you very much.